Example, a certain volume of hydrogen peroxide solution was decomposed in the presence of platinum. The amount of hydrogen peroxide remaining after time t was found by withdrawing aliquot portion of the solution, adding dilute tetraoxosulfate 6 and titrating with potassium manganate, tetraoxomanganate 4 oxide, 7 oxide solution. Looking at this table, A, show that the reaction is a first order reaction. B, calculate the rate of constant K for the reaction. Solution. We have from the question time is equals to 0, 20, 40, 60, 80 and 100. Then the initial concentration is 27.3. 27.3, 27.3, 27.3, 27.3, 27.3. Initial concentration minus the volume of the product. We have that 27.3 minus 27.3 will give us 0. 27.3 minus 17 will give us 10.0. 27.3 minus 10.3 will give us 17. 27.3 minus 6.3 will give us 20. 27.3 minus 3.8 will give us 23.5. 27.3 minus 1.3 will give us 25. So if you do the log of a over a minus x to the base 10, we have 0 for the 0 for the time 0, 20 for the 0.204 for the time 20, we have 0.2041. For the time 40, we have 0.04232. For the time 60, we have 0.6268. For the time 80, we have 0.8564. For the time 100, we have 1.0745. Then we can now calculate the constant by substituting the values we have. For the time 0, we have nothing. For the time 20, we have 2.34 times 10 raised to the power minus 2. For the time 40, we have 2.43 times 10 raised to the power minus 2. For the time 60, we have 2.44 times 10 raised to the power minus 2. For the time 80, we have 2.43 times 10 raised to the power minus 2. For the time 100, we have 2.47 times 10 raised to the power minus 2. The plot of the graph is a straight line graph. The graph of log a over a minus x to the base 10 against time in minutes. Since the graph is a good straight line, the reaction is the first order one. B, rate constant K is equals to slope times 2.30 minutes per slope of AC is equals to AB over BC, which is equals to 0.525 over 50, which is giving us 0.0105. We now have 0.0105 times 2.303, which is giving us 2.42 times 10 raised to the power 3 minute per minute cube. Energetic. The total heat energy of a substance in kilojoule or joule is called heat enthalpy, represented by symbol H. It is not easy to measure the enthalpy of the number of substances. The energy change delta H is more easily measured. Delta H is the heat change or enthalpy change during reaction. Delta H is equal to H1 minus H2, where H1 is the total heat content before a change and H2 is the total heat content after the change. Exothermic reaction. It is the type of reaction in which heat evolves or liberated in the environment and delta H is negative. Endothermic reaction. It is the type of reaction in which heat is absorbed from the environment and delta H is positive. Heat of formation. This is the heat liberated or absorbed when 1 gram mole of the compound in its normal state is formed from the constituent element at constant temperature. Example, the heat of formation of sodium chloride is the heat liberated in the reaction. Sodium plus half chlorine to form sodium chloride. Delta H is 418 kilojoules per mole. Heat of combustion. This is the quantity of heat evolved when 1 mole of substance is completely burnt in oxygen at constant temperature. Example, maintain CH4 plus 2 moles of oxygen gas to give carbon dioxide gas and water, 2 moles of water liquid. Delta H is equals to minus 891 kilojoule per mole. Heat of reaction. This is the heat change when the number of gram mole of substance as represented by the chemical equation has completely reacted. Carbon dioxide plus half oxygen to give carbon dioxide. Delta H is equal to minus 287 kilojoules per mole. Heat of reaction is also the difference between the total heat of formation of the product and that of reactant. For the reaction, R plus S to give S plus Y. Reactant, the left side is reactant, the right part is product. Delta H or heat of reaction is equal to total heat of formation of product S plus Y minus total heat of reaction of the reactant R plus X. Example 1. From the equation Cs plus O2 gas to give CO2 carbon dioxide gas, delta H is equals to minus 393 kilojoule per mole. Hydrogen gas plus half of oxygen gas to give water, delta H is minus 286 kilojoule per mole. Calculate the heat of formation of ethane. The heat of combustion of ethane is equals to 1500